Good morning, good afternoon, or good evening, whatever the case may be. Welcome back, AP Stats students. Today we're going to start Chapter 9. This lesson is very short, and it's just basically vocabulary. And the topic is sampling distributions. All right, so here we go, some vocab. First word is, that's out of order. There we go. Our first word is a parameter. All right, this is a word you should already be familiar with. We've used it in the past. Remember that a parameter is a number that's the perfectly accurate value from a population. Okay, so if you deal with cards, dice, flipping coins, things like that, you have the ability to have the parameter. You know exactly how many cards there are, you know how many of them are red, you know how many of them are hearts, you know anything you want to know. So you can get at the parameter. Now, when you have the parameter, you're going to use certain symbols. Symbols like mu, that's the parameter for mean. Sigma, that's the parameter for standard deviation. Okay. Now, oftentimes though, especially when we deal with human populations, we can't actually get the exact parameter. And that's what statistics is really all about. So that's our next word. The word is statistic. Okay. When I can't get at the exact population parameter, I have to use a statistic to approximate it. And then the way I get my statistic is by taking a sample, of course, right? We've talked about sampling methods in the past. So once you do that, you create a statistic and you're going to use different symbols, right? These symbols are for statistics, right? You put a bar on top of something, that means the mean, but it means it's a sample mean. It's a statistic. You use S for the sample standard deviation as opposed to sigma for the population standard deviation. Remember that actually has a slightly different calculation, right? Sigma you divide by n, whereas S you will be dividing by n minus 1. And here we go. This is what I was saying. The point of statistics is to use them to estimate the unknown parameters. All right, so that's what we're going to be doing. Now, when we do it, we're not going to get the same exact answer from every sample, right? One sample will be a little lower than the true parameter. Another sample might be higher. Another sample might be right on the money, who knows? But we're going to get variation from one sample to the next, right? And we really don't know if we only take one sample, if it was too low, too high, or right on the money. We have no idea. But we do know that if I repeatedly do it, I will get variation. Some will be too low, some will be too high, some will be right on the money, okay? And that's the idea of a sampling distribution, okay? So if you were to repeatedly sample over and over and over again using the same method, you're going to get some that are too low, some that are too high, some that are right on the money. And that will create a distribution. Okay? And we call that a sampling distribution. Now, formal inference is based on these sampling distributions. That's where we're headed. We're going to be doing formal inference in chapters 10, 11, 12, 13, and 14. Okay, next words. Bias. Okay. This is a word, again, you should already be familiar with. We talked about bias back in chapter 5 when we were talking about data collection methods. Remember that something that's biased has a systematic favoritism of one outcome or multiple outcomes over other outcomes, right? So we're favoring some outcome or outcomes, okay? Which means it's going to pull us off the true mark. It's going to move us away from the true parameter, or in other words, pull us off center. Maybe systematically favoring low, maybe systematically favoring high results. All right, our last word is the word variability. Again, you should know this word, right? We've talked about it way back in chapter 1. We have statistics that measure variability. Things things like variance, things like standard deviation. Right? So remember, variability is how spread out your data is, right? So some sampling distributions are more spread out than others, right? Or in other words, they have higher variability than others. Now, if you want to control well, let's talk about controlling both. If you want to control bias, that is controlled by using proper sampling techniques, right? If you want to control your variability, well, that's controlled by the size of your sample. Larger samples will have less variation. Smaller samples will have more variation. As simple as that. Okay? But these are two things we want to control. All right, so let me illustrate these two vocabulary words graphically. Okay, so I have 4 different graphs here. Let's look at the top 2 graphs. How would you describe the variability of the data in the top 2 graphs? Okay, hopefully you would say, they both have quite a bit of variability, right? They're both pretty spread out. What about the bias for the top 2 graphs? Right, here's the true centers marked. You see the graph on the left, the data is pretty much centered correctly, meaning little to no bias, right? So the sampling technique on this was excellent, little to no bias. But there was quite a bit of variability, so it could easily be corrected by simply using the same sampling method and increasing the sample size if you wanted to have less variability. But this is data we can work with, right? Because it is on the mark. Okay, over here, we have a lot of bias. This is very high bias. It makes it useless, right? As soon as you introduce bias to your data set, it's useless because your data is off center and you really have no way of knowing how it's off center. Is it too low? Is it too high? How far is it too low? How far is it too high? You have no way of knowing. So once there's bias in your data collection, it's useless. Bad data. All right, look at these 2 bottom graphs now. Okay, how would you describe the variability on these 2 distributions? Okay, these both have low variability. So in other words, the sample size that was chosen was quite good. It led to low variability. What about bias? Okay. This one over here, way off the mark. Really, really large bias. Again, useless. Once there's bias in the data, you can't use the data to approximate the parameter because it's off the mark. And you don't even know which way or how far it's off the mark. You just know that it's bad data. That's all you can say, all you can conclude. So that's useless. But over here on the right, hey, low bias, low variability. This is like the researcher's dream, right? We're pretty much on target. We don't have a lot of spread, so we can make pretty accurate estimates of the parameter. We can make good conclusions about whatever it is that we're trying to study. So that's great. This one up here, we can work with, but the bias, no good. All right, so that's a visual. Hopefully that illustrates those 2 vocabulary terms and they make sense now. All right, that's all I have. Like I said, it's a short lesson. Whenever you have a lesson like this that's about vocabulary, please make sure to take the time to read the book and focus on learning the vocabulary because we will be using these terms throughout the semester. All right, so have a good morning, a good afternoon, or a good evening, whatever the case may be, and I will see you in class.